Good morning, everyone. My name is Paul Steckler, National Product Manager with Graybar. I would like to welcome you to Graybar's G2Talk presentation on the 5 myths of electrical design in hazardous locations. This talk is part of a webinar series we offer each month for our industrial customers. We have a great discussion lined up for you today, but before we get started, I would like to cover a few housekeeping items. First of all, if you were one of the first 50 people who joined in on the presentation, you will receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, at the bottom of your screen, you'll see a box for Q&A. Feel free to submit questions throughout the presentation. We'll address as many as we can at the end. Lastly, our G2Talk webinar series is archived on graybar.com. So you'll be able to view this presentation again or recommend it to others. We're happy to team up today with Hoffman. As an electrical distributor, Graybar works alongside Hoffman to provide industrial-grade equipment protection solutions for a wide variety of environments and applications. You can visit graybar.com/industrial to learn more about our solutions. At this time, I'm happy to introduce today's speaker, Matt Behrens. Matt is the Director of Global Marketing for Hoffman and Graybar. Prior to this position, he was the Oil and Gas Vertical Marketing Manager with special focus on hazardous location applications. He has an electrical engineering and physics degrees with extensive experience in process automation and instrumentation. Before joining Hoffman, Matt was a global product manager at Emerson Process Management for over 6 years, where he focused on wireless technology applications. So without further delay, I would like to turn the presentation over to Matt. Matt, the floor is yours.
Okay, well, thank you everyone for joining me today, and I'd like to thank Graybar for the opportunity. So what are we going to talk about today? We're going to first kick off with a bit of a hazardous location, certification, and standards overview. I always like to start at some of the basics and then build on some of those concepts. And then we'll talk more specifically about protection concepts and some of the associated myths with them. So to get started, we start at the very basics, and we say, what are hazardous locations? Well, there are areas where there's flammable liquids, gases, dust, vapors that create a risk for a fire or an explosion. And why does this matter? Well, arcs, sparks, high heat environments can create a situation that could be dangerous and create a potential explosion. And electrical equipment can do those sorts of things. So they're present in lots of different industries, obviously oil and gas, whether offshore or onshore, petrochemical plants, chemical plants, but there's also other applications like coal dust in a power generation plant or food processing areas, water and wastewater treatment. So present in many different industries and applications, and we have to be thoughtful on how we design electrical equipment in these applications. So when we look at the industry standards, there's really 3 main ones across the world. If you look at outside the United States, North America, and outside the European Union, we have the IECEx standard, and that's being broadly adopted across the world. And then those set of standards are really adopted into a set of directives for the ATEX standards, which is essentially law in the European Union. So ATEX and IECEx are similar. There's some slight nuances between the two, but when you see like a product certification, typically they have both ATEX and IECEx certifications together because they're very similar. In North America, you have lots of different standards, whether it's the National Electrical Code, Canadian Electrical Code, OSHA, NFPA. It's kind of lots of compilations there. But the NEC 500 is the most common, has been used for decades, and is obviously broadly adopted in the United States as well as in Mexico. And so standards really vary by region. There are also country-specific certifications. So if you go to like Brazil, there's an in-metro certification, but that's broadly based on the IECEx standard. And so some of those standards do exist by country. Russia, China, Brazil are some examples. So you have to be conscious of what standards are applicable for where your equipment is going to be installed. So let's talk about the class and division classification system, which is used by the NEC 500 code. What that code does is basically says, let's break things into 3 different classes. Class 1 is for gas, liquids, and vapors. Class 2 is for dust. So think of agricultural applications or coal-fired power plants, for example, would have Class 2 areas. Class 3 is for fibers and flying, so that's broadly kind of textiles, for example. Class 1 is the most commonly used and deployed, which is oil and gas, petrochemical, chemical plants. So once you define the class, there are different divisions. In this example, we see here a tank, and a Division 1 is an area where you have continuous or intermittent or periodic exposure. So if you're installing equipment on the tank that's full with gasoline, for example, or equipment really close to that tank, you're typically in a Division 1 area. Division 2 is when that hazardous material is present only during an abnormal condition. So they break things up into those Division 1, Division 2 areas. They're very technical definitions of what a Class 1 or what a Division 1 is versus Division 2, but in layman's terms, this is how they are applied. So what types of enclosures and solutions can we use in different classes and divisions? So this is a bit of an eye chart, but it's a good reference table to kind of figure out what technologies you can use in different areas. So Class 1, Division 1, you have three options. You have explosion-proof, which is kind of a traditional NEMA Type 7 enclosure, heavy cast, very well constructed enclosure with lots of bolts around it. I'm sure many of you are familiar with them. The idea here is that it allows explosions to actually occur within the enclosure, but it contains and extinguishes the flame and cools gases as it leaves. You can purge and pressurize a general purpose enclosure, which means you can use general purpose electrical equipment in a NEMA Type 4 or 4X enclosure by using a purge device and system to put inert or compressed air into the enclosure to keep hazardous gas outside of the enclosure and outside the control panel. Another alternative is intrinsically safe. This is kind of low power equipment, limits the amount of energy in the electrical circuit, and typically you would use a NEMA Type 4, 4X, or 12 enclosure with that type of equipment in a Class 1 Division 1 area. Class 1 Division 2, you can use any Class 1 Division 1 solution, and then you have another two options. You could use a NEMA Type 4, 4X, or 12 enclosure with rated electrical components. So the components are actually rated for Division 2 areas. They're non-incentive, they're non-arcing, and we'll explain what that means in a couple of slides here. You can also purge a general purpose enclosure, and that's just called a Type Z purge. Very similar concept to what we talked about already, but you have that option available to you. In Class 2 Division 1, you can use a dust ignition-proof enclosure. It's a little heavier duty, thicker gauge enclosure called the NEMA Type 9, and the idea is they want you to be able to thread in conduit entries into the enclosure and seal it. You can also pressurize a general purpose enclosure to keep flammable dust outside of the enclosure. Class 2 Division 2 and Class 3 applications, you really just need a dust-tight enclosure, so NEMA Type 3, 4, 4X, or 12 are perfectly applicable in those environments. Now we switch gears. Now we think about the international standards outside the United States. You look at ATEX and IECEx zone classification system. So what these standards do is they break things into zone 0, 1, and 2, and those are for gas, liquids, and vapors. Again, thinking about oil and gas, petrochemical applications. And then they break things into zone 2.0, 2.1, and 2.2 for dust, fibers, and flyings. It's a little different in terms of how they break them up into three different zones. So a zone 0 is where you have continuous exposure to hazardous material. So lots of applications here are kind of low power instrumentation that's being installed on a tank to measure the liquid level, for example, of that tank. Zone 1 is where you see more control panel type applications where you have more intermittent or periodic exposure to hazardous material. And then zone 2 is when you have an abnormal condition when that hazardous material is present. So if we focus on zone 0, 1, and 2, what types of solutions are available to you? Well, like I said before, a zone 0, typically you don't see a lot of control panel applications there, but what you do see is low power instrumentation, like pressure and temperature transmitters. Really the idea is you're limiting the amount of energy in the electrical circuit to those transmitters, so you really can't create a dangerous situation. If you were for some reason needing to have a control panel that was Zone 0 certified, which would be really rare, you would need to have that entire system tested and certified by a third party. Zone 1, you have 3 kind of different options. Core options is what I'll call them for control panels. You have FLAMEPROOF, which is similar to explosion-proof. The idea here is it contains the explosion, quenches a flame as those explosions exit kind of the enclosure. We'll talk more about that as we move forward. You can purge and pressurize, which we've already talked about, or you can use a concept called increased safety. Increased safety looks like an IP66 type of an enclosure, but the components that are being used within it don't arc, they don't spark, and they don't create hot surface temperatures on the enclosure themselves. Typically terminal boxes and control stations. In Zone 2, you can use any Zone 1 solution, but you have some other components or other tricks in your bag, if you will. You can use non-sparking, non-incendive, hermetically sealed components, and you can use those components as a completely certified assembly with an increased safety certified enclosure is what typically we see in those environments. So that was a brief overview on standards. You can go to 3-day classes on standards in infinite detail. Obviously, we don't have time for that today. So I want to go through today in a little more detail is protection concept overview and some of those 5 myths explained as we go through the different protection concepts. So here's the most commonly used protection concept in hazardous areas, so explosion-proof and flame-proof enclosures. They're applicable in Zone 1, 2, or Class 1 Division 1 areas, also known as a NEMA Type 7 enclosure. Again, a very heavy-duty enclosure designed to allow hazardous gases to enter the enclosure, and if there's arcing and sparking equipment, it created a dangerous situation. That explosion can occur, but the enclosure is strong enough and to withstand the explosion to start, but also has highly machined surfaces to cool the gases as they leave the enclosure. So the pros, this is highly proven, very well adopted in the marketplace, very robust, allows for high power equipment to be used, so it's not limited to low power applications, but there are some challenges associated with this type of solution. One is really long-term equipment reliability, especially when it comes to heat and humidity. So you see a lot of condensation management challenges when it comes to these types of enclosures. They just kind of trap the heat within them and the humidity, especially when you've got large temperature swing environments, especially if you're near a coastal environment. High cost of wiring and conduit and sealed fittings. It takes time to install these enclosures. You have to use lots of different sealed fittings with pretty specific installation practices. And so that kind of drives up the cost. And then you're supposed to go do some regular maintenance. Every year you're supposed to go look at the enclosure and make sure that the enclosure's integrity is intact. Another thing is it's difficult to modify in the field. You can't modify them really. You need obviously special equipment to actually drill and tap and make holes in the enclosure themselves. But broad set of applications, power distribution and panel boards, control stations, motor starters for local starting and control, lots of different applications. So there's some advantages, there's some disadvantages with this type of solution. So one of the most common myths that we hear from customers is, I have to use an explosion-proof enclosure in a hazardous area. And the point is that explosion-proof is proven, it's got a great use case, but you do have alternatives. So purge and pressurization, you can install general purpose and components into a hazardous area, and you have to have compressed air available. So if you have that available to you, that might be a good alternative, especially for large control panels. Intrinsically safe is a great alternative if you're doing low power, instrumentation type applications. Increased safety is really only applicable to ATEX and IECEx, but it's great if you can use non-arcing and sparking components like terminal blocks or operators that are certified. So those are alternatives that can be lower cost or a better solution for various applications. In Division 2, Zone 2 areas, You can use rated components, non-arcing, non-sparking, non-incendive components, and then use them with like a Type 4 or 4X or IP66 certified enclosure. Again, just different alternatives that would lower the cost, ease installation, and help kind of ensure some reliability aspects to it. If you look at like a Division II application with a drive, you could always use a purge system to install that drive in that area, and then you can use cooling if you wanted to help cool that product to keep it reliable over a long time. Purge and pressurization, we've referred to this a lot already. It's a very simple protection concept. You're just taking compressed air or inert air, you're putting it into an enclosure to keep hazardous gas out. So it's a two-step process. The first step is purging, which removes the hazardous gas from the interior of the enclosure. You do that through a series of what they call air exchanges. And then once all the hazardous gas is out of the system, you can pressurize, and all you're trying to do is maintain a higher internal pressure with a protective gas supply to prevent hazardous gases from entering the enclosure itself. Again, very simple protection concept. There are some advantages. It's the only technology to really allow a general purpose enclosure as well as general purpose electrical equipment in a hazardous area. Advantages, again, you can use widely available products, and there's not a lot of system design necessarily as there are with intrinsically safe circuitry. You can use a larger enclosure footprint and use cooling, whether it's passive, which we show here with a solar shield, that would be called passive cooling with solar shielding, or you could use active cooling, whether you're talking about a vortex cooler or an air conditioner. You have options. And design flexibility and lower cost. Again, if you have a large footprint where you have a lot of equipment you want to install in a hazardous area, put them in an explosion-proof enclosure, for example, could be very cost-prohibitive. So this is a lower-cost alternative. There are some disadvantages and challenges in terms of you have to have inert or instrument air available to you to start with, but it has to be clean. If you have, a lot of moisture or condensation in your instrument air or oil in your instrument air, you obviously do not want to be putting that into your control panel near all your, valuable controls and PLCs and distributed control systems, for example. So you want to put in some provisions there to make sure you're getting clean air into the enclosure itself. One question we get a lot of is annual operating costs for purge. So how much does it cost to do this? There's a lot of misconceptions that it's really expensive to operate. And, of course, the answer is it depends on how expensive it is annually to operate it. But we've done a bit of math, and we did it here in this table. And if you're looking at, a small enclosure and using purge technology that doesn't consume a lot of air, and you have a pretty low enclosure leakage, annual operating costs could be $50. If you have a really large control panel and your purge technology is really consuming a lot of air and you're losing air out of the enclosure, it could cost you up to $700. And we pulled this information, doing some of our own calculations, but also looked at kind of compressed air costs according to the U.S. Department of Energy. These slides and this presentation will be available to you, and we provided a link there for you to look up different costing so you can help estimate yourself. But really, the annual operating cost is not really that high if you think about it over the life of the control panel. So one thing I've talked about there is having excessive leakage. And what did I mean by that? Well, there's a misconception out there that I can use any enclosure for purge. And the standards really set a minimum requirement, meaning I need a Type 4, 4X, or 12, or IP40 enclosure. But that doesn't mean that there's not going to be a lot of excessive air leakage out of the enclosure when you're putting compressed air into it. The funny thing about enclosures is all of them are designed to keep stuff out of it. They're not necessarily designed to keep and hold a purge well. So we do have some design best practices when it comes to having a good enclosure for purge. One is using a fully welded enclosure. We manufacture modular enclosures. We just don't think it's a good idea to purge them. There's a lot of different connection points, and they struggle to hold purge well. Using type 4, 4X, or IP65 enclosures is a bare minimum. Using center posts on a multi-door enclosure, you don't want to have overlapping doors. That's just another leakage point. You want to have a centering post. When it comes to the latching mechanism, using things that are welded on the enclosure on the outside, such as like a NEMA clamp or a traditional NEMA clamp, they hold the purge the best. And using a continuous piano hinge is the best hinge configuration. So we've got a couple enclosures here on the right of the slide that kind of show what those look like. While they're not necessarily convenient to open, they do hold the purge the best. Latching, if you do have different hinging or latching points, you want them to be 15 inches or less apart from each other. And then if you have any empty holes, you obviously want to fill them with a properly rated device. So there are hole seals out there that are ATEX, IECEx, and UL certified, and they can hold purge very well with this heavy-duty gasket that's around it. Okay, so we're moving on to another protection concept called increased safety, and this is for ATEX and IECEx standards. So it's applicable in Zone 1 and Zone 2. What makes these enclosures and systems a little unique is at a bare minimum they've got to be IP54, but typically you see IP66 performance. They have internal grounding and bonding provisions, and they have been tested extensively. They've been tested for high heat, humidity, low temperature, and then there's a lot of impact resistance testing that has to occur. And then you go through that testing, and the IP ratings have to be maintained after it goes through that pretty rigorous testing profile. Another thing that happens is that the entire electrical assembly is tested and certified for thermal rise. So the key here is you're using non-arcing, non-sparking equipment like terminal blocks or operators like a pilot light or a switch that's certified for a Zone 1 or Zone 2 area. But you want to test this assembly with power applied over its broad ambient temperature range to make sure that the enclosure can't get to a high enough temperature that could cause an ignition. So it goes through a pretty rigorous testing profile to make sure that it fits the application and keeps the environment safe. It's a lower cost alternative for terminal boxes when we compare them to FLAMEPROOF. Again, you're using what looks like an IP66 enclosure with some special features. It's a little lower cost than FLAMEPROOF enclosures. One of the biggest challenges that we see with ATEX and IECEx control panels is customers asking, well, how does this whole system get certified? So in the UL world, there are UL certified control panels or even ETL certified control, we call them control panel programs that integrators or OEMs can get engaged with those certifying bodies so that they can do some certification of Class 1 Division 2 or Class 1 Division 1 control panels. In the ATEX and IECEx world, that doesn't really exist. There's no control panel or no systems integrator program. So one of the questions we get is, can I certify this panel if I put equipment into a Zone 1 enclosure, or can I certify this panel if I add certified devices into an IP66 enclosure? And the broad answer is really no. In ATEX Zone 01 or IECEx Zone 01 or 2, you have to have the system evaluated by a notified body. So they have to go through, evaluate your design, evaluate the system, go through the testing, and certify it. The only place where you can do some self-declaration of compliance is for ATEX Zone 2, but you still have to go through all the rigorous testing that's required by the standards. So the point is adding ATEX or IECEx certified equipment to an enclosure doesn't really guarantee the assembly is certified, nor does adding general purpose equipment to a certified enclosure guarantee that the entire system is certified. Our best practice is to really engage with notified bodies to really make sure that you're meeting the standard requirements, and use a certified enclosure as part of your system so that you can speed up the certification process. A lot of times certifying bodies, it depends on your application, but they will look at the test profiles and say, well, we know the enclosure already passes all these different tests that are specifically for the enclosure, so you might only have to test the electrical system, if you will, rather than just the enclosure. So just some advice on that. Intrinsically safe, it's another alternative protection concept. What it does is it uses an intrinsically safe barrier or isolator to limit power that goes to a hazardous area, typically to an intrinsically safe sensor or instrument. Really prevents explosions from occurring because there's not enough power to create a dangerous situation. It's applicable in all hazardous areas, and it allows lower cost enclosures to be used in Class 1 Division 2 areas, like a NEMA Type 4, 4X, or 12. The challenge with it is it does require some upfront engineering design and documentation to make sure that the electrical properties of the circuit are accurate and work, and make sure that it maintains intrinsically safe properties. And it's not really suitable for high power equipment or devices. So you're really looking at 24 volt, 300 milliamps or less type systems. So it's not for high power applications. So really you're looking at instrumentation, low power solenoids, or terminal boxes or simple control stations for this type of application. There are other alternative protection concepts, so hermetically sealed. This basically means the equipment is sealed, doesn't really allow hazardous gases to be allowed into the system. Typically it's an all welded construction. Non-incentive, really any arc or thermal effect is really not capable of igniting a flame, or not sparking means the system or the electrical component really isn't going to normally arc under normal conditions. The pros: allows a lower cost enclosure solution, type 4, 4X, or 12, or you can use increased safety enclosures. They're easier to maintain, and they have lower installation costs. The cons is really it's only applicable to Zone 2, Division 2 areas. It's not suitable for Zone 1 or Division 1 areas. And there's also some limitations on what electrical equipment are available with these ratings, so you have to investigate that. Typically, you see remote I/O, terminal boxes. There are some PLCs that have Class 1 Division 2 certifications on them, or Zone 2 certifications. So it's something to be aware of. When we see these applications in Class 1 Division 2 or Zone 2 areas, especially Division 2, we get these requests of saying, I need a certified Division 2 enclosure. And there's no such thing as an empty enclosure that is certified for Division 2. What the NEC 500 standard says is that for Division 2 areas, NEMA 4, 4X, or 12 enclosures can be used in those environments so long as the equipment installed in them do not constitute a source of ignition under normal operating conditions. So the point being is that the certification for Division 2 is all about the final assembly with all the components as part of the system, not the enclosure itself. So again, the NEC 500 really focuses on assemblies, and Division 2 enclosures don't really exist, if you will, as an empty enclosure on themselves. Cooling and heating in hazardous areas. So why would you need to cool or heat? Well, heat really impacts equipment reliability and life. You know, for every 10 degrees Celsius or 18 degrees Celsius, you cut electronics life in half if you go over room temperature. So you may want to protect some really critical equipment like a variable frequency drive, a distributed control system, a critical PLC controlling a processing unit or process equipment. You may want to protect that and make sure you give it that long-term longevity over time so you don't have failures in the field. In addition to that, those pieces of equipment can generate heat themselves, and the ambient conditions can generate a lot of heat. So you put a stainless steel enclosure outdoors in a really sunny area, there's going to be a lot of solar heat gain, as well as the ambient temperature around it creating a lot of heat gain, and the temperatures can get quite hot, you know, up to 120 degrees Fahrenheit, and you're going to want to cool that control panel to keep your equipment operating within their designed limits. Hot processes or processing units create temperature challenges. So if you're by a driving oven, a furnace, a boiler, they can all create higher or hotter ambient temperatures. And then obviously when you're extremely cold environments like northern Alberta or Russia, they can create extremely cold environments where you need to warm or keep equipment warm so they don't shut down on you. Some reasons why you may have to use cooling equipment in a hazardous area is you might not have available footprint to take a control panel outside of a hazardous area. So if you're on an offshore platform, you have a lot of constraints on where you can put equipment. So you may have to put it into a hazardous area. Also, you may want to put a control panel really close to an operating unit to save on wiring costs. There's other reasons to do that, but if you want to put it near an operating unit, you might have to put a control panel in the Division 2 area, and you may want to cool. And so one of the biggest misconceptions that we get is it's really difficult to cool or heat in a hazardous area. And the point is that you have options. So you can use an air conditioner where it cools below ambient temperature. Again, the air conditioner is sealed, so it prevents dust and water contaminants from going into the control panel, and it can provide up to 12,000 BTU an hour of cooling capacity, and they're Class 1 Division 2 certified, so larger control panel like a distributed control system or a PLC cabinet, for example. Heat exchangers really transfer heat away from the enclosure. Air to water would cool below ambient temperature. Air to air cools just above ambient temperature. Again, it's a sealed system, so it prevents dust and water from entering the cabinet, and they can be Class 1 Division 2 certified. If you're purging an enclosure, you can use Vortex. Vortex just uses compressed air as a source and creates and cools the enclosure. It can do up to 5,000 BTUs an hour of capacity. Again, it's a sealed system, and it can be Class 1 Division 2 certified when used with a purge system. And then heating, there's lots of different options for heating, but typically what you see is a Class 1 Division 1 certified heater that can be used in a Division 2 area. It could provide up to 600 watts of heating capacity. And the key here is there's really two applications. One is to warm electrical components in cold environments or to help reduce condensation challenges. And you would use this with a breather drain, for example, to help keep and manage condensation challenges. So the point is you have options with cooling and heating in hazardous areas. So kind of a quick summary. Hazardous location certification requirements are regionally diverse. Our advice is really engage with notified bodies and product experts to get the right solution for your application. You have a lot of application solutions. You have a lot of solutions at your disposal. There's different myths associated with it. Looking at explosion or flame-proof, the point again is you have options like purge, intrinsically safe, or increased safety solutions. When you're looking at purge applications, really look at the enclosure design and make sure you're adding the right latching provisions to make sure that you're able to hold purge and you'll have a lot of air leakage out of the enclosure. Again, when you're looking at ATEX and IECEx control panels, engage with a notified body if you're going to do a design for ATEX Zone 1 or Zone 2. We just think that that's a best practice, and it's a requirement for ATEX Zone 0, 1 and IECEx Zone 0, 1, and 2. For Division 2 applications, if you're using certified components in your system, you just need a NEMA 4 4X12 enclosure, nothing more than that. And then cooling and heating in areas, you have options: air conditioners, heat exchangers, vortex coolers, and then just simple heaters. You have lots of different options to protect equipment in hazardous areas, and so hopefully you got a little more educated on what your options are to help consider for future designs or new applications. So where do you go to get more information? Well, the webinar recording will be available. You can go to pentairprotect.com/oil and gas and click Contact an Expert if you want to engage with someone directly on how to design a system or get some input or feedback. We also have a cooling selection tool. It's a 7-step guide, really simple, to help you pick the right cooling solution for your application. And so it helps you select, do you need a vortex cooler versus an air conditioner versus a filter fan, for example, for general purpose applications or for hazardous location applications. And this is kind of my concluding slide. You know, Hoffman, we obviously have a broad set of solutions for lots of different industrial applications, but we do have a pretty solid hazardous location offering ranging from flame-proof and explosion-proof enclosures. Our ZoneX enclosure line is for the increased safety protection concept for ATEX and IECEx, and you can use them for junction boxes or control stations. We have PURGE systems, and then cooling, we have enclosure air conditioners for Class 1 Division 2 areas. Vortex coolers are Class 1 Division 2 certified as well as heaters and thermostats. And then we have a wide variety of accessories, whether you're looking at a simple window kit, a light, hole seals to help seal up extra push-button holes or conduit openings, or breather drains to help manage moisture buildup and condensation within enclosures. So with that, thank you for your time, and we can open it up to questions, and I guess I'll turn it over to Paul.
Well, thank you, Matt. Excellent presentation. Yeah, as you mentioned, at this time, we'd like to address some of the questions that have been submitted. As a reminder, you can submit a question using the Q&A box down at the bottom of your screen. If we don't get to one of your questions, a Graybar representative will follow up with you after the presentation. First question here, what types of applications typically require cooling?
I break it down into two situations, really. One is where you have a lot of heat in a control panel and you got to get it to 95 degrees or 100 degrees or below. Obviously, high ambient conditions or high solar gain applications create that challenge. But also just critical equipment. I mean, you think about a distributed control system or a PLC control panel that's controlling some critical equipment or a drive. You want to protect that equipment to make sure that it doesn't fail in the field. Obviously, that creates all sorts of headaches and loss of production and things of that nature. So those are the typical applications, the kind of way I break it out and think about it.
Great. How often does a Class 1 Div 1 enclosure need to be maintained, and what type of maintenance needs to be performed?
Typically, it's on your typical kind of product maintenance or instrumentation or control panel maintenance cycle. It's typically annually. And really, you're just trying to make sure that the integrity of the enclosure is maintained. So your flame paths are being maintained well. They don't have a lot of rust on them or buildup, and they have all the bolts and nuts on the actual assembly. I can't tell you how many times I've been in the field and seen removed bolts and what have you from control panels. It's obviously not a safe scenario. So that's kind of what you're trying to do, is just go evaluate it and make sure that the integrity of the entire enclosure is being maintained.
Okay, well, great. Is Class 1 Div 1 the same as Zone 0?
I would say that they are similar, but Class 1 Division 1, really, if you were to try an analogy between the class and division system and the zone system, Class 1 Division 1 is similar to Zone 0 and Zone 1. Class 1 Division 2 is similar to Zone 2. But I will say that they are very different standards. And so equipment that are being installed in those environments, you really just have to look at the standard requirements and make sure that you're meeting those specific standards. So you can't just design a Zone 0 type application and then try to say, oh, I'm going to go put it into a Division 1 area. That doesn't necessarily work that way.
Okay, thank you. Are there cooling options other than vortex coolers for Class 2 Div 2 locations?
For Class 2 Division 2 locations, God, that's a really good question. I don't know offhand if there are other options. There's two ways you could do cooling, and it depends on this person's application. One is if it was for some reason an outdoor environment, you could obviously do passive cooling, where you took a solar shield, for example, and put white paint on it to help reflect away some of the solar heat gain. Vortex coolers are an option. I don't know of any certified air conditioners for Class 2 Division 2 environments, nor do I know of any heat exchangers certified for those environments off the top of my head.
All right. Is a notified body the same as a UL 508A shop?
No, a notified body is someone like ETL or CIRA, who is a part of the CSA group. UL is also a notified body. UL, for example, would then go and say, okay, this panel shop meets the requirements. They go through the audits. They go through the process for that panel shop to become a UL 508A shop. UL also has a program called UL 698 or UL NNNY, where these panel shops can go and do value-add work and create Class 1 Division 1 or Class 1 Division 2 assemblies. But obviously the capability really depends on, what that panel shop is certified to do. That information is actually out on UL's website, just as an example, so you can go find out who's on the hazardous location control panel program, and you can go find out the right person. And there's a fair amount of them. There's about 300 different panel shops within the United States that can do hazardous location assemblies.
Okay, great. Is there a tool out there to calculate solar gain?
Yeah. I don't know if there's a great tool out there to create solar gain. That's good feedback. We have some charts and tables that could help, kind of guesstimate what solar gain would be, but I don't have like a nice automated tool off the shelf that would help calculate that.
Okay, just a couple more here. Can IS barriers and enclosures be located in hazardous areas?
No, my understanding is that IS barriers should be deployed outside of a hazardous area, and then that wiring can go into a hazardous area once it leaves the barrier. But the barrier itself has to be in a non-classified area.
Okay, one more here. Is the evaluation of a system nearly the same as having UL listing?
It's similar. So UL listing, right, is basically you've gone to a panel shop, an OEM, that said, I can UL list this entire panel, but now they have to be obviously part of UL's program to be able to do that. When I'm talking about having a system evaluated, a lot of times what I'm more referring to is going to a notified body like an Intertech or a CIRA, UL, and having that entire system evaluated to be Zone 1, Zone 2 certified for ATEX and IECEx. In the Class and Division world, like I said, there's panel shop programs that allow those panel shops to create Class 1, Division 1, or Class 1, Division 2 certified panels based on a UL or ETL program. So they're similar.
Okay, great. Thank you very much, Matt. We're about out of time at this point. If we didn't get to your question, a Graybar representative will follow up with you after the presentation. As a reminder, this presentation will be archived on graybar.com. So again, go out there and you can view it, recommend it to others. Thank you for your time today. We hope you'll join us next month for our next Graybar G2Talk seminar. Thank you very much.